In this session, I'll be discussing about the kinetics of drug elimination. So whenever any drug is eliminated from the body, the drug will either follow the first order kinetics or the drug might follow the zero order kinetics. So the whole focus of this discussion is going to be what is the difference between first order kinetics and the zero order kinetics. For this, I have noted 5 points to differentiate the first order kinetics from the zero order kinetics. And I'll go point by point to understand what is the difference between these two orders of kinetics. Let's take the first point, which is elimination per unit time. That means how much amount of the drug gets eliminated per unit time. In the first order kinetics, fixed fraction of the drug gets eliminated per unit time. Now to understand this, first let's understand, or to remember, easy to remember is F for F, which means in the first order kinetics, fixed fraction of the drug gets eliminated from the body. Now what does it mean? If you carefully look at these black numbers, 100 converted into 50, 50 is getting converted into 25, 25 is getting converted into 12.5. That means in 1 unit of time, 50% drug is getting eliminated from here. In the next 1 unit of time, another 50% drug is getting eliminated from here. In the next unit of time, another 50% drug is getting eliminated from the body. That means in each unit of time, fixed fraction, that is 50% of the drug is eliminated from the body, and that is called as the first order kinetics. Whereas in the zero order kinetics, again focus on the black numbers 400, 300, 200 and 100. That means in each unit time 100 is getting eliminated. That means in the first unit of time 100 is getting eliminated. In second unit of time another 100 is getting eliminated, and in the third again 100 is getting eliminated. That means fixed amount is getting eliminated. So that is the basic difference between the first order kinetics and the zero order kinetics in terms of elimination per unit time. The second point is about the rate of elimination. Now if you look at the rate of elimination, in the first unit time 50 is eliminated, that means 100 has become 50, that means 50 has been eliminated. In the second unit of time 50 has become 25, that means 25 has been eliminated. In the third unit of time 25 has become 12.5, that means again 12.5 has been eliminated. Now what it suggests is that in the first order kinetics, the rate of elimination is directly proportional to plasma concentration. Now what does it mean? When 50 is getting eliminated, the concentration is 100. When 25 is getting eliminated, the concentration is 50. When 12.5 is getting eliminated, the concentration is 25. That means the rate of elimination is directly proportional to plasma concentration. That means if plasma concentration is more amount of the drug will get eliminated if the drug is following first order kinetics. What happens in the zero order kinetics? In the first unit of time, 100 has been eliminated. In the second unit of time, another 100 has been eliminated. In the third, again 100 has been eliminated. So irrespective of the concentration, whether it is 400, 300, 200, the amount that is getting eliminated is fixed. That means the rate of elimination does not depend on the plasma concentration, because the amount is same, fixed amount is getting eliminated. That means rate of elimination does not depend on plasma concentration in zero order kinetics. That is the second difference. Now to get into better understanding, I'll give a simple example. If you are traveling by a car and there's a weekend, there are so many cars coming after your car and you go on a toll booth. Now because there are so many cars and the number of cars is getting increased in number, the traffic police might help you, or he might open another lane for the cars to go. So that means more cars are coming and the more cars are being relieved from that particular toll because the number of cars is increasing. So that means if the concentration is more amount of the drug will get eliminated from the body. That is about the rate of elimination. Whereas in the zero order kinetics, you are in the car, there are so many cars behind you, but there is a barricade which is made up of metal which cannot be moved from there. At one point, only one car will go. That means the rate of elimination will not depend upon the plasma concentration. The number of cars moving from that barricade will not depend upon what is the number of cars behind you. That is the second point of rate of elimination. The third point is about the clearance. Now, to understand the concept of clearance, we have to understand the formula, and the formula is rate of elimination divided by plasma concentration. So clearance is calculated by the formula rate of elimination divided by plasma concentration. Now rate of elimination here in the first order kinetics in this case was 50. Now this 50 and concentration was 100. So 50 divided by 100, it becomes 0.5. So on this side, the blue numbers are about the clearance. So concentrate on the blue numbers which are about the clearance. So clearance is calculated by as a formula by the rate of elimination by plasma concentration. The rate of elimination here is 50, plasma concentration is 100. So that means the clearance becomes 0.5. When you come here, the rate of elimination becomes 25 and the plasma concentration becomes 50. That means the clearance again becomes 0.5. Here the rate of elimination is 12.5 and the plasma concentration is 25. Again the clearance becomes 0.5. That means in the first order kinetics, clearance remains constant because these numbers are same. Whereas in case of the zero order kinetics, the rate of elimination here is 100, plasma concentration is 400. So 100 divided by 400 becomes 0.25. Here the rate of elimination is 100, but the plasma concentration is 300. So 100 divided by 300, it becomes 0.33. Here the rate of elimination is 100, plasma concentration is 50, so it becomes 0.5. So what it means is that the clearance is inversely proportional to plasma concentration. Now look at the blue numbers and look at the black numbers. If the black number is more, the blue number is lesser. 400, 0.25, 300, 0.33, 200, 0.5. That means the lesser is the plasma concentration, more is the rate of elimination. So that's how the clearance in the zero order kinetics is inversely proportional to plasma concentration. The last point is about the half-life. Now look at the half-lives on this side. 100 has become 50, that half-life is 1. So half-life means the amount of the time which is taken by the drug to reduce the concentration to 50% of its original value. Now if you look at the half-lives here, 100 has become 50 in 1 unit time, that is 1 hour suppose. 50 has become 25 again in 1 hour. 25 has become 12.5 again in 1 hour. That means again in the first order kinetics, half-life remains constant. Whereas in zero order kinetics, if you look at this 400, to become 400 to get converted into 200, we needed 2 half-lives. This is 1 half-life, this is another half-life. So 2 half-lives are required. To convert this 300 to 150, we needed 1.5 half-lives. And to convert this 200 to 100, we needed 1 half-life. What it means is that the half-life in zero order kinetics is directly proportional to plasma concentration. Look at these numbers, black color numbers, and look at the half-lives. So it clearly suggests that in zero order kinetics, half-life is directly proportional to the plasma concentration, which means if the plasma concentration is lower, the half-life is lesser. If plasma concentration is more, the half-life is more. And the last point about the examples of the drug which follow first order kinetics and zero order kinetics. So the most of the drugs, they follow first order kinetics. Few drugs, they follow zero order kinetics. For example, alcohol. Alcohol follows zero order kinetics. Phenytoin follows zero order kinetics. Just to summarize, elimination per unit time. In case of first order kinetics, fixed fraction of the drug is eliminated per unit time. In the zero order kinetics, fixed amount of the drug is eliminated per unit time. As far as the rate of elimination is concerned, in the first order kinetics, rate of elimination is directly proportional to plasma concentration, whereas in zero order kinetics, the rate of elimination is not dependent on the plasma concentration. As far as the clearance is concerned, in the first order kinetics, clearance is constant, whereas in case of zero order kinetics, the clearance is inversely proportional to plasma concentration. And lastly, the half-life is constant in first order kinetics and it is directly proportional to the plasma concentration in the zero order kinetics. Most drugs, they follow first order kinetics, and drugs like alcohol, phenytoin and some, they follow zero order kinetics. Thank you.